Hello everyone and welcome back. In this session, we will take a look at the persistence profile. In the previous session, we had a look on TCP profile. Now we're going to talk about persistence profile or stickiness. This is where you have a requirement that says the client should be going to the same server regardless of the load balancing algorithm for a specific period of time. I want to make sure that when client 1 connect to the virtual server for the first time, so the virtual server load balancing method says go to server 2. So client 1, go to server 2. Now, within the upcoming 10 minutes or 15 minutes, I want every time client 1 interact with the application, he still goes to the same pool member, go to server 2. This is the requirement for persistence or stickiness. Now, how do we achieve this? We need to create a persistence profile and we need to use a persistence method. The two main persistence methods are the cookie using the browser cookie and source or destination IP address. We will test and lab each one of them. Now, when we want to use the cookie, we have actually 4 different options to choose from. Now, the first one is the cookie hash, and let's talk about it on the whiteboard. So let me just clear up a little bit the mess. Yeah. Now, our requirement says that when client 1 connect to the virtual server and then the big IB do the load balancing algorithm, then we send him to server 2, for example. I want client 1 always go to server 2 for a specific period of time. Or as long as the session is opened by client 2, the browser session is opened, he did not close the application, I want him always to go to server 2. This is the persistence, and this is a requirement for most of the e-commerce applications or e-commerce websites. So if you are shopping, for example, from eBay, and you are selecting items, so you add item 1, item 2 to your cart. So you have 2 items in your cart, but for some reason you left the device. Maybe you go prepare some coffee, grab some coffee. Maybe you got a phone call, you are talking, and then you didn't interact with the eBay website for 5 minutes, and then your connection timed out. Then you go back to continue shopping and add a new item to the cart, and you don't see the previous 2 items on the cart. That's maybe because on your previous session you were sent to server 1, so you added 2 items on server 1. So the server 1, he knows that your cart is filled up with 2 items, but because your connection timed out and then you started again and you are adding a new item, but the load balancing decided to send you to server 3. Now on server 3, you will not see the 2 items that you have added on server 1 because there is no real-time synchronization between the servers. So you go to server 3, your cart is empty, so you add the 3rd item, but you don't see the previous 2 items. So e-commerce websites usually they apply some kind of stickiness or persistence so that the same customer goes to the same node for specific period of time or for the lifetime of the session. As long as your browser is open to the e-commerce website, you will continue to go to the same node. So now to go back to the cookie hash, method, if we want to use persistence with cookie hash method, the server within his response will be already sending cookie. Let's say, for example, cookie 1. So even without the load balancer, if the client connect to the server already inserting cookie for his own functionality. Now, when the response from the server come back to the big IB, so the big IB will inspect, he will see a cookie 1. He will hash this cookie, create a hash value of the cookie and say, okay, now I have hash 1 going to server 2. So he will hash the cookie and link it, create a link for this hash to the server 2. So that now client 1, when he submit the next request, even if this request after the connection timeout, even if this request after 10 minutes or 15 minutes. So you kept the browser open, you go for like 10 minutes, 15 minutes phone call, and you come back. When you start interacting with the application again, your browser will automatically include cookie 1 in the request. So once the request come to the big IB, the big IB will check the request. He will see cookie 1. He will hash the cookie 1 and look in the table. Do we have hash 1? Yes. To which server? Server 2. So your second request will go to server 2. You will not be going to server 1 or server 3 based on the load balancing algorithm. No. You will be sent to the same server that match your cookie hash value. So you always go to the same server. But this method is dependent on the application server. So the application server should already be generating and inserting cookie. Now, to be on the safe side, we always use the default one, which is the insert cookie. So whether the application server is inserting a cookie or creating a cookie for the client response or not, we configure the big IB to insert cookie. So let's clean this. So client 1 send request. We do load balancing. We send him to server 1. Now server 1 responds. Now here, the big IB will insert cookie. The big IB will insert cookie. This cookie will be containing the node information, the client and the node information. It will contain kind of a hash value. Using that hash value, the big IB will be able to identify the client and the server. So the response to the client will go back, but within the response, there is a cookie. Now, the client did not interact with the website, with the e-commerce website for 10 minutes, 20 minutes, 40 minutes, whatever. Then after a while, we send a new request, start interacting with the website, checking some items. Now the request come to big IB. The request will come including the cookie. So because there is a cookie, your browser will include the cookie in the request. So the big IB will receive a request, will look at the cookie. This is a big IB cookie. Check the hash value, identify the server. So we can see that this client should be persistent with server 1 as per the cookie. So we send him back to server 1. We don't send him to server 2 or server 3. In fact, let's look at this in the lab, and then we'll go back to go through the other methods so that it becomes more clear. Let's sign in. Now, let's look at the pool and make sure that at least we have 2 members active in the pool. Now let's go to profiles, persistence, profiles. So there are already default profile, which we don't want to use. As usual, we create a new profile. We select the type cookie, the parent profile cookie, so we inherit, and let's call it cookie profile test. Now, the default is cookie insert. The default persistence timeout. So for how long I will be sticking to server 1 if I go to server 1 or server 2. By default, it is for the lifetime of the session. As long as your browser is open with the web application, the session is still open so that you will always go to the same server. Now, you can change this behavior and put a certain time, but for this testing, let's now test the session. Click finish. Now we have our cookies persistence profile. We have to go to the virtual server and attach this profile to the virtual server. Go to resource tab. This is where you select your default persistence profile. Now, before linking the profile to the virtual server, let's test and see that there are no cookies as of now. Let's open browser session and let's go to the server, to the virtual server. So we're on server 1. If you click on the page, right click on the page, inspect element. If you go to the storage, you see there are no cookies right now associated with this IP address, with this application. No cookies. We don't have any cookie used. If you click on refresh, you will go to server 1, server 3, server 1, server 3 as per the round robin algorithm. So there is no stickiness here, there is no persistence. Let's go back to the virtual server and let's select cookie persistence profile test. Click update. Now we have the profile associated with the virtual server. Let's go back to the testing machine and let's click refresh. Now we go to server 1. If you continue to click refresh for how much time you want, you will continue to go to server 1. And obviously you can see that there is a cookie now. And you see that the cookie name is Big IB Server Pool Web Application 1. So you see the pool name here. So using this cookie, when you click refresh, the cookie will be included within the request. And we can test this. So let's open the Wireshark. Let's start capture. So let's click refresh. Let me clear the capture. And let's click refresh on the browser. And let's go and see the HTTP request. Let's see the HTTP request. Let's look for a cookie that is included within the HTTP request. There you go. This is the cookie. So the browser behavior is when you have a cookie associated with a website or IP address or application, every time you interact with the application, the cookie will be included within your request. Now on the Big IB, when the Big IB sees a request coming with this cookie, he will immediately identify, yeah, this is a Big IB cookie, and this hash value will tell the Big IB to which server to send the user. As I said, by default, the stickiness or the persistence will continue as long as the session is open, as long as the browser session is open. Now, there is no chance that we go to server 3 or any other server. So this is how the cookie persistence work. The big IB will insert a cookie that is named big IB with the pool name, so that all the next requests coming from the same client will include this cookie, so that the big IB will know that this user uh, came before and we sent him to server 2, so we need to send him again to the same server because we need persistence. The other two methods that we can choose is passive cookie. Passive cookie assume that the web server already injecting a cookie with the appropriate information. Appropriate information similar to the cookie structure that the big IB usually insert, so that the big IB, there is no need to hash the cookie, there is no need to insert a cookie. So the cookie is coming back from the web server ready, already include the information that the big IB wanted to identify the node. So this is a passive cookie. Cookie rewrite, this is where the web server will insert an empty cookie and the big IB will rewrite. So as I said, the most common one used is the insert cookie. So the big IB will insert his own cookie within the server response going to the client, so that the client next time will include the cookie within the request. The other type of persistence that we can look at is the source or destination IP persistence. Let's test this. Let's go back to the big IB. This is our persistence profile. Let's create source IP profile test. We use source address affinity. The timeout for the persistence record is 3 minutes. So with the source IP address, the timeout is 3 minutes. So even if you kept the browser session open, but you did not interact with the application, you are idle for more than 3 minutes, the persistence record will be deleted. So if you open the virtual server, you go to server 1, you leave it for 4 minutes, you come back, there is no guarantee you go back to the same server. Now, this is the default, you can increase. Let's stick with the default now and let's see how this will work. Let's go to the virtual server and let's change the persistence profile to be the source IP. Let's go back to the testing machine. Let's close the window. This testing machine is configured with the IP address .16. So let's open Firefox and say 192. Or we go to server 1. As per our configuration, based on the source IP, we will always send the same source IP to the same server. So if we try to click refresh, it's always going to the same server. Always going to the same server. Now, on big IB, there should be a place where it keeps the information that 100.16 going to server 81. This is what they call persistence record. If I go to statistics, module statistics, local traffic, open the statistics type, go to persistence record. Now it says persistence record cannot be shown on the GUI until we execute this command. So let's copy this command, go to the command line, paste the command, Go back to the GUI, click refresh. Now we see that we have a persistence record for the IP address .16 says send this record to, send this client, the source IP address, send him to pool 1. It should expire after 180 seconds as per the, if we go to the persistence profile, if you remember, the timeout was 180 seconds. So if we give it 180 seconds, it should expire. So I'll stop the recording and then we will come back. So as you can see now, the record has reached 170 seconds almost. So we should be expecting the record to disappear after 180 seconds. Now the record is no longer there. Now, if I come back to the testing server, close the Firefox, just to make sure there is no record, we open the Firefox again. Now we have been sent. Let me just click refresh just to make sure. Yes, we did go to the same server again. That's not because of the persistence, it's just because of the load balancing. And you can see that we have the record again from the same source going to server 1. Let's use another testing machine. Let's use our second testing machine. This testing machine 100.15. So 192. Now we go to server 3. Now we can see that we go to server 3. Now no matter how many refresh I click, I will always go to server 3 for 180 seconds. I will stick to server 3 for 180 seconds. If I go back to the persistence records, now I see that server 15, user.15 going to server 3. You see two records here actually because I'm clicking Control F5 refresh to force it to kind of open new connection with the server. So now we can see that we have two persistence records within the persistence table. So for the period of 180 seconds, every time .15 come, we will send him to server 3. Even if I go back, close the browser, open another browser, open a new private window on the Google Chrome, I will still go to server 3. Close the Google Chrome. Let's try Edge. Go to server 3. So no matter what you try to do, as long as you are coming to the big IP from the same source IP, you will always go to server 3. You will always go to server 3. Now, let's change the IP address. Yeah. So instead of 15, let's say 155. Okay. Okay. Now open the Firefox again. 192. Now we go to server 3, but let's see the persistence records. Now you can see there is a new client coming. Let's change the IP address again. So let's make it 157. close Firefox. Let's use Edge. Yeah, it was cached page. So now I can see that I go to server 1. If I go to the persistence record again, you see 157 has been sent to server 1. So you see that every single source IP address will have a persistent record going to specific server. This is how the source IP persistence work. Now, let me go to the whiteboard. Let's go to the whiteboard and we'll discuss this source IP persistence, because we have a couple of options that we can configure. So we have client 1 with the IP address .15, 192.168. Now we have client 2, 192.168.100.16. Then we have client 3.17, for example, and so on and so forth. So when the client connect to the virtual server, then the big IB will choose a server to serve the client. Then the big IB will maintain a persistence record in a persistence table, saying that .15 goes to server 1. Now when client 2 connects, as per the load balancing, he will go to server 2. So .16 go to server 2 and .17 go to server 3. And this persistence record will be valid for 180 seconds, which is 3 minutes. Every time within the 3 minutes, client 1 try to interact with the application, send request, all the requests will go to server 1 as per the persistence record. So the point here is the persistence source IP by default is /32. So each different IP address will have different persistence record and different server depending on the load balancing algorithm. Now, what we can do is we can configure the persistence with different subnet mask. For example, let's customize now our profile so that the persistence will be /24. The results should be that, let's say, for example, client 2 started. He is the first one. He talked to the virtual server, and then the virtual server sent him to server 3. Within the persistence records table, the big IB will say 192.168.100.0/24 go to server 3. The whole subnet will be sticked to server 3. So now client 3 come to the big IB. This persistence record will apply to client 3. So client 3 will go to server 3. Now client 1 come, client 1 will go to server 3. So the whole subnet will be sent to server 3 for the period of 180 seconds. Let's test this. Let's go to our profile and let's change the prefix linked. So click on this, specify the IP version 4/ or just 24. Click update. Let's make sure there are no records within the persistence records table, so no one has persistence. Let's go to our testing machine, close. This is which one? .15. So let's open Firefox, private window 192. Now we are on server 1. We go back. What record? You see 100.0, go to server 1. Let's go to the other testing machine, the one that this is .16. Close the Firefox. Let's use Edge. (192). We go to server 1. Try to refresh. Control F5. Go back to the persistence records. Nothing new. Let's change the IP address on the other testing machine, the one that we were changing. Let's say 222. Close. Open Google Chrome. Just now we go to the same server. Go back to the persistence records. No changes. Why? It's just it is refreshing the 180 seconds because someone is using the record, so it's not idle. So click refresh. Control F5 a couple of times. Go back. So the counter is starting again. Let's change the IP one more time. Make it back 15. Close. Let's use Edge here as well. Now we go back to server 1. Control F5. Still on the server 1. See the timers. Reset the timer again. Why? Because someone is using the record. So any source IP address that is part of this subnet will go to server 1 because of the persistence profile is configured to take /24. So same apply to any other subnet mask you want to configure. So say for example, if you want to say /25, if we configure the persistence on /25, so still those three IP address, they fit in the same part. So 100. Now if we have client with IP address 192.168.100.200, once he connects, let's say for example the big ID send him to server 2, so there will be a record 192.168.100.128, the subnet go to server 2. This is based on the /25 subnet mask. So this is about the source IP persistence. You can play with the subnet mask. You can change the timeout, increase or decrease as per. Now, the last point that I wanted to talk about the persistence is the fallback persistence profile. So let's say, for example, you are using cookie as a first persistence profile, and for any reason, maybe you are using passive cookie, which assume that the server is inserting a cookie for the big IP to take a decision to send the user to the same server. So this passive cookie is dependent on the fact that the server will insert appropriate cookie. So if the server failed to insert the cookie, or if the cookie does not have the information that the big IP require to achieve persistence, so the default persistence profile will fail. So you can configure it to fall back to another profile. So if the cookie doesn't work, then fall back to the source IP and do persistence based on the source IP. So you can have primary persistence profile and fallback persistence profile. Let's just now remove the persistence so that ما في داعي لآخر هيك the requirement.